Hello, algebra students. Mr. Lawrence here. Today we're going to explore zero and negative exponents. And my first question for you is about zero exponents. I guess I should put the word exponents there. And do you know what 5 to the 0 power is? And I know a lot of you are just going to throw out guesses without even thinking. Um, I don't want you to guess. I want you to be smart when you do it. Let's take a look at a little table here. I've got 5 cubed, 5 squared, 5 to the first. 5 cubed is 125, is it not? 5 times 5 times 5. And 5 squared is, here, let me even do it this way. It would be 5 times 5 times 5, which is 125, right? Well, 5 to the second would be 5 times 5, which is 25. And notice that there's one less 5, right? It's kind of like I divide by 5 as I move down. All right, and then 5 to the first. It's just a plain old 5. And isn't that the same as dividing by 5? So if we're going to follow that pattern, 5 to the 0 must be this number divided by 5. Well, what is 5 divided by 5? It's 1. Yeah, it's 1. So when I had 5 to the third, to move to 5 to the second, I divided by 5. To move from 5 to the second to 5 to the first, I divided by 5. 5 to the first to 5 to 0, I divided by 5, so I get 1. Now, let me erase these. I think those are important, but I'm going to rewrite those answers in there. Oops, looks like I lost my equal sign. That's okay. Get it right back there. Get my calligraphy pen back in mode. And I know that this was 125, and this was 25, and this was plain old 5, and then this was 1. 5 to the 0 is 1. Let's look at that from another perspective. We know that when we divide like bases, we subtract the exponents. So wouldn't this be 5 to the 2 minus 2 power? And isn't 2 minus 2 0? Of course. But what is any non-zero number divided by itself? I mean, this is 25, right? And 5 squared is 25. And what's 25 divided by 5? Excuse me, divided by 25. It's 1. You see how I got a 1 over here? Equals, 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 equals. That means 5 to the 0 power equals 1. These two endpoints are equal to each other. So 5 to the 0 is 1. What do you think 7 to the 0 power is? Well, maybe it's 7 to the 8th divided by 7 to the 8th, which would be 7 to the 8 minus 8, or 7 to the 0, right? Well, that's going to be 1. Yeah. Now, be careful, because 0 to the 0 power, if you try to explain it using this, you'd go, well, 0 to the 10th, 0 divided by 0 to the 10th, whoop, 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 danger, Will Robinson, danger, danger, danger. What did I just do right there? Right there, I broke a law of mathematics. Divide by 0, error. Cannot do it, cannot do it. This problem is undefined. We don't say no solution because we're not solving for anything. We say it's undefined. There is no definition that allows us to divide by 0. All right, so that's anything to the 0 power is 1 except for 0. So if I add a googol and I raise it to the power of 0, I get 1. All right, now, what do you suppose happens with negative exponents? Like 2 to the negative third. Well, some of you are going to think the answer is negative, and you are absolutely wrong. Let's continue our table here. I've got 5 to the third, 5 to the second, 5 to the first, 5 to the 0. Wouldn't 5 to the negative first come next, and 5 to the negative second, and 5 to the negative third? Now, some of you run your calculators way too early. Didn't we learn that we want to divide by 5 here? And then divide by 5 again, right? And every time we move down the column, we're dividing by 5. So let me ask you this. What's 1 divided by 5? And do not tell me 0.2. Another way to say 1 divided by 5 is 1/5. Hey, look at this. This is kind of cool. Where are my highlighters? Oh, highlighters, where are you? Oh, highlighter. 5 to the first was 5. 5 to the negative first, 1 over 5. I don't know about you, I think that's pretty cool. I'm wondering if that's a coinky-dink. All right, let's see. How about 5 to the negative second? Well, if I divide 1 to the fifth, divide by 5, which is the same as times 1 to the fifth, I get 1 over 25, aren't I? 1/25. Oh, look at that. You know what, let me do this. Let me move him here, clone him, and there you go. And then I'll also clone him, and look at that. 5 to the second is 25. 5 to the negative second is 1 over 25. Well, if you have half a brain, and I know you guys are way smarter than a kid with half a brain, then you should know that 5 to the negative third is the same as 5 to the third, except it's 1 over that. And there you go. Pretty simple. So, how would I do 2 to the negative third? Well, I know that 2 to the third, I know 2 to the third is 8. 2 to the negative third must be 1 over 8. 6 squared? Well, 6 squared is 36. 6 to the negative second must be 1 over 36. I like to say that a negative exponent means use the stairs, meaning the numerator comes to the denominator comes to the numerator. Okay? Upstairs, downstairs in the fraction. How about this? How about 1/7 to the negative second? Well, wouldn't that be the same as 7 to the second power, or 49? Right? Because 1/7 to the second power would be 1 over 49. 1 times 1 is 1. 7 times 7 is 49. So the negative second must be the reciprocal. Yeah, pretty cool stuff. All right, let's try some examples here. C to the negative fourth times c to the fourth. Well, I could do that using the laws of adding exponents because the bases are the same. That'll be c to the negative 4 plus 4 power, which is c to the 0, which equals 1. That is one good way to do it. Or if I wanted to, I could turn this one so it was 1 over c to the fourth times c to the fourth over 1. And then these guys cancel, leaving 1 times 1, or 1. Okay, maybe now you're starting to see why I harped on you about fractions so much at the beginning of the year. Maybe. All right, let's try this one. I'm going to do my d's, and I'm going to get a d to the negative second. Here, I'm going to get f to the 0 power. Now, I don't like to write answers with negative exponents, so this d to the negative second is going to be the same as 1 over d to the second, and this is 1, so there's my answer. Now, just another note on that one, I really like to think about it this way too. If I have d to the fourth over d to the sixth, the numerator is this, and the denominator is this, right? Those are all d's, by the way, sorry. And then I can cancel, 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 cancel. There's a 1 left. And I've got d times d, so I get 1 over d squared. Of course, the f's turn to f to the 0, and so there's nothing, it's just a 1, so I don't bother to write it. Okay, when I have a problem like number 4, well, I know 4/12 is the same as 1/3. C to the 4th divided by c to the 4th, that's going to be c to the 0, or just plain old 1. D to the 5th, d to the 8th. I could say it's d to the negative 3rd, but remember, I don't like to write my answers with a negative exponent. That's just kind of a law in math. You don't give a negative exponent in the answer. And so I'm going to take that d cubed downstairs, and there is your answer. I didn't quite get rid of that. All right. All right, how about this one? We're going to go 25. 5 squared is 25. Now we're going to have negative 3 to the second power. That's going to be negative 6. X to the negative 6th. Y squared will be y to the 4th. Z will be to the negative 10th power. But I don't like that answer because I have negative exponents. So my 25 has a positive exponent. He's staying put. Positive exponents do not move. Okay, y to the 4th has a positive exponent. He's not moving. The x to the 6th is going to go downstairs, and his going to become positive, and then z to the negative 10th is going to become z to the 10th. Okay, so it ends up being 25 y to the 4th over x to the 6th, z to the 10th. I want to do one more of those. Make sure you're comfortable with what's going on here. All right, so let me get my calligraphy pen out. Let's say we have a negative 3 x to the 5th, y to the negative 2nd, z to the negative 3rd. Well, let's raise that to, I don't know, the 5th power. Okay? Now, I know lots of different ways to deal with this. This is one good way. I'm going to take negative 3 to the 5th power. And let me see. Negative 3 to the 4th is 81 times negative 3 is going to be a negative 243. Okay? I'm going to get an x to the 25th power, right? And then I'm going to get y to the negative 2nd to the 5th power. It's going to be y to the negative 10th, and then z to the negative 15th, right? Now, these negative exponents tell me to use the stairs, right? So I'm going to use the stairs. So my numerator, the negative 243, has a positive exponent, namely 1. It's going to stay in the numerator. X to the 25th has a positive numerator, so it's going to stay in the numerator. Positive exponent, so it's going to stay in the numerator. The y to the negative 10th is going to go downstairs and get a positive exponent, and the z to the negative 15th will also go downstairs and get a positive exponent. And there you go. All right, that's going to be the lesson for today. Hopefully you took notes, watched it more than once if you needed to. And that'll be it. Mr. Lawrence signing off. Good night, everybody.